Welcome to Slope Day 2. Yesterday we focused on finding the slope given 2 points or given a table. Today our goal is going to be to recognize and determine the slope of a line given a graph or an equation. Again, we want to show that mastery by scoring at least an 80% on an exit ticket in class tomorrow. Now, you should have in front of you your notes. If you got them from me during class, you may take them on there. If you did not and you still decided to watch this video, that's fine. Either take notes on a separate sheet of paper, or if you have printer capabilities, you can print the notes out from Google Classroom. Yesterday we talked about horizontal and vertical lines, and an undefined slope, and a zero slope. Today I'm going to introduce to you a little acronym to help you remember the difference. It's going to be called HOI-VUX. In HOI-VUX, we have H for horizontal lines, and if you forgot, horizontal lines go from left to right. They have a slope equal to 0, and all your equations are going to be in the form of y equals a number. So we could have, for example, y equals 4, y equals -1, so on and so forth, but it is y equals a number. So again, HOI is horizontal with a 0 slope. It is your y equals equations. When we talk about VUX, V is for vertical, and vertical goes top to bottom. Our slopes, as for U, is undefined. So anytime you see a vertical line, it is an undefined slope. These equations all are going to be x equals a number. Again, it does not matter if x equals 4, x equals -2. There is no y, and it is just x equals. Now, these become important when we talk about slopes of graphs, because sometimes you're going to have just a graph and asked to define it. Now, if we look, yesterday we said slope was the change in y over the change in x. Well, now we're saying it is rise over run. If we talk about rise over run, rise is like going vertically, and that's exactly where our y-axis is. Running, you run horizontally. That's where your x-axis is. So it's still the change in y over change in x. It just looks a little different. When it comes to a graph, you need to start by picking 2 points that fall right on integer coordinates. We don't want anything that falls in between. We want them to fall on integers. So I'm going to put dots there to remind myself. Then I'm going to make a triangle connecting those dots. My longest side is the graph itself, but I'm going to go up and over. From here, we want to count. And we always want to start at the point that's towards the left. So I'm going to start at my point, and I'm going to count 1, 2, 3, 4, 5. I moved +5 boxes up. Then, if I look at moving over to get to my second point, I move 1, 2, 3, and it's +3 boxes to the right. I'm going in the positive x direction. So, for my slope of m, I want rise over run. Well, my rise is my y, and I moved +5 spots in the y direction, and I moved +3 spots in the x direction. We cannot simplify this fraction, so that is your final answer. If we look at our second graph, again, we're going to start with our points. If you picked different points than I did on the graph, you will still get the same answer once you reduce your overall fraction. Again, I'm going to start with my point that is to the left, and I'm going to follow my triangle. Well, I took one step down. Since I'm going down, I'm calling that a -1. From there, I moved 1, 2 spots to the right. We're moving in the positive x direction, so that is +2. For slope, again, m is equal to rise over run. In my y direction, I went -1. In my x direction, I went +2. Because I cannot reduce that fraction, it is in simplest form. It is our slope of the graph. Now, if you had picked a different point farther down the graph, you will get a different fraction. However, if you reduce that fraction, you will still end up with a -1/2 as your final answer for your slope. That's the nice thing about graphs. As long as you pick 2 points that fall at integer locations and use them, you will still end up with the same slope. This unit, we're going to have quite a few equations that we're going to have to see different forms of. Today, we're starting with slope-intercept form. The big thing with slope-intercept form to remember, M is always going to stand for your slope. B is always going to stand for your y-intercept. Anytime you have an equation in slope-intercept form, the y equals mx plus b, M is going to be your slope and B is your intercept. So, if I look at example 1, I have y equals -2x plus 5. Well, if I go based off what I said earlier, and I use exactly what I said, M is my slope. M is the number being multiplied by x. In this equation, -2 is the number being multiplied by x. It's x's coefficient. So my slope in example number 1 is -2. If I look at example number 2, I need the coefficient of x again. If I look, 1/4 is the coefficient. So my slope equals 1/4. Now, if I look at example number 3, I only have y equals x. There is no coefficient. But remember, in class, we've said it time and time again, you can always put a 1 there if there is not a coefficient. So in this case, my slope equals +1. We cannot say 0 just because there is not a number there. Make sure it is +1. In the case of example number 4, this goes back to Hoi Vux. If I have Hoi, that tells me it's a horizontal line with a 0 slope in the form of y equals. Well, here is my y equals equation. So my slope equals 0. Number 5, that is our Vux. We have a vertical line with an undefined slope if we have an x equals equation. Well, I have x equals -3. So my slope is undefined. Again, please keep in mind there is a difference between undefined and 0. 0 is a number. Undefined means there is no slope. The next type of equation we're going to see, and we have worked on this in class, is standard form. ax plus by equals c. For these types of equations, you need to turn them into slope-intercept form. And if you already forgot, your slope-intercept form, y equals mx plus b, where m is my slope and b is my y-intercept. So, if we solve it, we need this y by itself. So I'm going to subtract 3x on both sides. Those 3x's canceled, and I'm left with y equals -3x minus 5. Please keep in mind when you write these problems, you always want your variables to come first. So make sure -3x comes before -5. Now that I have it in slope-intercept form, I can easily look at it and say -3 is my slope. When we look at example number 2, again, we want this y by itself. So I'm going to start by subtracting the 4x. Inverse operations tell me those cancel. I'm left with -2y equals -4x plus 3. Y is still not by itself. It's being multiplied by -2. So I need to divide both sides by -2. To help yourself, divide both terms on the right-hand side by -2. I'm left with y equals -4 divided by -2 is a +2x. +3 divided by -2 is a -3/2. Again, I am now in Slope-intercept form, I have my m and my b. So if I look, 2 is my coefficient of x. That is the slope of the line. Please make sure to complete your practice problems again tonight. Turn them in to me first thing when you come into class. Make sure you are showing your work for these. If there is no work, you will not receive credit. If you choose, you may still work with me again tomorrow, or you may begin the second activity. Look forward to seeing you in class tomorrow.